This video is brought to you by mywayteaching.com.
Next is Lewis dot structure. The Lewis dot structures provides a picture of bonding in molecules and ions in terms of the shared pair of electrons and the octet rule, which such a picture may not explain the bonding and behavior of a molecule completely. What is that? The picture. So example, this is chlorine plus chlorine. So if it is sharing the pair of electrons and all, what I explained you. So this gives what? Chlorine and chlorine single covalent bond. So this is not explain the bonding and behavior of the molecule completely. It does help in understanding the formation and properties of molecules to large extent. Writing of Lewis dot structures of molecule is therefore very useful. The Lewis dot structures can be written by adopting following steps. Some of the steps are there so that we can easily adapt how to write. The first one is the total number of, you have to calculate the total number of electrons required for writing the structure are obtained by adding the valence electrons combining the combining atoms. Example, see, you should know what how many number of electrons are present and how many number of valence electrons are there. So here molecules, there are 8 valence electrons available for bonding in CH4 molecule. Total number 8 electrons, that is valence electrons in this molecule. They are for bonding. They are available for bonding. That is 4 from the carbon and these are the 4 from the, this is which forms 8 electrons. Okay, hydrogen. Next, second step. For anions, each negative anions, each, okay, for anions, each anions, each negative charge would mean addition of one electron. Anions, if there is a negative, it means addition of one electron. It means for cations, the positive charge that would be result in a subtraction of one electron from it. This is addition, this is subtraction. Okay, subtraction of one electron from the total number of valence electrons. So this is about anions and cations. Next, third one, knowing the chemical symbols of combining atoms and having the knowledge of a skeletal structure of the compound, it is easy to distribute the total number of electrons as bonding shared pairs between the atoms in proportion to the total bonds. We should have the knowledge of structural skeletal structure. Okay, next, fourth, in general the least negative electronegative atom occupies the central position. So what is the least electronegative atom occupies central position? Least, this occupies a central position in the central position in the molecular ion. Okay, and the next thing is fifth one, after accounting for shared pairs of electrons for single bonds, the remaining electron pairs are either utilized for multiple bonding or remain as the lone pairs. So after sharing, after shared pair of electrons, okay, after shared pair of electrons for single bonds, after pairing shared pair of electrons for single bonds, the remaining electron pairs are either be the remaining can either be utilized for multiple bonding or remain as one pairs. Okay, so this is about how we can, these are the steps. First one is we have to find out the number of valence electrons. This is the example. And the anion, it negative means addition of one electron, cation means positive. Okay, then subtraction of one electron from it, and we should have the knowledge of skeletal structure. The least electronegative atom that occupies a central position, okay, and after the shared pair of electrons and forming a single covalent bond, if still again any charges are remaining, so its electrons are remaining, it is used for multiple bonding. Next is one problem can solve based on this. Write the Lewis dot structure for CO molecule. Write the Lewis dot structure of CO molecule. Okay, the step 1, count the total number of valence electrons of carbon and oxygen. First, count number of electrons in both carbon and oxygen. Okay, so that is outer valence shell configuration of carbon and oxygen. Carbon and oxygen electronic configuration, outer electronic configuration is 3 2s square 2p square. This is for the carbon, and the next one is for oxygen is 2s square and 2p4. Next step is skeletal structure. How we can write skeletal structure? C and O. Okay, next in that the third step is third step. So for in the first step we have to count the total number of the valence electrons, and we have to write the configuration, electronic configuration, and after that we should know the skeletal structure. Okay, then the third step is draw a single bond. Draw a single bond. Okay, draw a single bond between carbon and oxygen and complete the octet on first. Complete the octet octet on oxygen. Okay, the remaining two electrons remaining two electrons are the lone pair on C, and two electrons are the lone pair on C. See, I will write here. This is the carbon and this is oxygen. This is the second step what we have discussed. Okay, this is the skeletal. And you know, in the carbon, how many number of electrons are there? 4 number of electrons. This is 1 and this is 2. This is I will write. And you know, in oxygen there are 6. 1, 2, 3, 4, 5 and 6 I will write. Okay. So then here, as here said, octet on oxygen. Okay. So first we have to make a octet on oxygen. Here 1, 2, 3, 4, 5, 6 and 7, 8 is there. So this is the, we have to make first octet on oxygen. Then remaining is only lone pair of electron on C. So wow, how we can write here? This is C. This is the one bond we did here. So uh, 3, 4, 5, 6, total 7, 8. So that this is the remaining electrons are 6 electrons, and this is sharing 2 and this is sharing 2. So that you formed here. You can write like this: C. This is oxygen. Okay. So what, how they are sharing, and it is forming, now it is having the octet 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is having octet structure. Next, then write down the fourth step. In the fourth step, the what I explained, so first make oxygen as octet. This does not complete the octet on carbon, and hence we have to resort to multiple bonding between C and O atoms. This satisfies the octet rule condition for both atoms. The octet sorry the octet rule condition should satisfy on both atoms. Okay, like so to carbon, and it should be satisfied to oxygen, not only to oxygen, it should be carbon also. So you know, this is the oxygen, this is the carbon, and this is the oxygen. Okay. So here hmm, the carbon should have also have the 8 electrons in with it. Okay, there are already 2 existing, so that you have to make 8. 3, 4, 6, 7, 8. 2, 4, 6, 8. So now 2, 4, 6 is over, and oxygen should have another 2 of electron. So by making this, so see here, now the carbon is also having, and oxygen is also having octet. Now we can write C 1, 2, 3 oxygen. So these are the again the remaining pair of electrons. So this is the what I want to explain you. This is okay. This is the Lewis structure in that. Okay, the next how carbon next. Okay, this is the third step and this is the fourth step problem. Okay, next. I will explain you another problem here. Write down the second problem. Write the Lewis structure of the nitrite ion in O2 minus. So in that step 1, count the total number of valence electrons of nitrogen atom and the oxygen atoms and the additional 1 negative charge. Okay, first count the number of electrons in both nitrogen and oxygen. You know, the nitrogen is equal to 2s square and 2p3. Okay, then for oxygen 2s square 2p4. Now for nitrogen, how many number of electrons? 5. Oxygen, this is 2, that's why 2 oxygen atoms, that's why 2, and 2 plus 4 plus 2 is 6. Correct. So that you are multiplying that into 6. Okay, there is your negative sign, so that if there is a negative sign we have to add 1. Okay, so it means it's gaining the electron. Then counting this, how much we are getting? 18 electrons. Okay, total number of 18 electrons. Next, in step 2 we have to write the skeletal structure. In skeletal structure there is a O, N and O. So this is the skeletal structure. Next, then the third step is draw a single bond between the nitrogen and each of the oxygen atoms, completing the octet on oxygen. So the skeletal structure is this one, and in that you have to make a octet structure first. Octet structure should be complete on oxygen. Okay, and this however does not complete the octet on nitrogen, we know that, and if the remaining 2 electrons constitutes the lone pair. So first you have to make oxygen. So we know there are the total of 18 number of electrons, and nitrogen, which is having the 5, plus this is 2 into 6. So 6 into 2 is how much? 6 12 plus 1, total 18. So that each is having the 6 electrons, correct? So first add down the electrons of oxygen. 2, 3, 4, 5, 6. Okay, total 5, 6 number of it. And write down the number of electrons nitrogen. 5 plus 1 you consider. This is including that nitrogen only. Okay. So you consider the remaining electrons 1, 2, 2, 3, 4, 5 and 6. Okay, so after that, as I said, you have to complete on oxygen first. Oxygen first means any one you consider here. So this is the oxygen 1, 2, 3, 4, 5 and 6. So again we should complete the octet structure on this, means this is 8. Okay, and then coming to this nitrogen 1, 2, 3 and sorry, this is 3, 4 and next come to the another oxygen 1, 2, 3, 4, 5 and 6. Okay, now you got the idea. This is the third step, and so now you completed. This is the here 8. So 2, 4, 6 and this is the 8. Okay, it's where it is shared, and I'm sorry, don't write here. Okay, see, you write here. This is a 6. This oxygen atom 2, 4, 6. So that 2, 4 and this is sharing, so that it will become 8, and for this is also 8. Now I can write or like this. Oxygen is of this. Okay, there is the 2 bonds N. Then this one is remaining electrons. Okay, so and you are making only one bond with this. Okay, like this with the this one. So that you are forming the, see here it is having the 8 electrons, and this is having the 8 electrons. So now the only one bond exists in between N and O. So the remaining O is how much? 1, 2, 3, 4, 5 and 6. Okay. So this is minus. You can write like this also. Okay. This is the problem. I think you got idea how to write the Lewis structure. First, count down the number of electrons. Okay. After this, write down the skeletal structure and how to share the electrons. You should know. This is the problem.